everyone. Welcome back to another episode of Physics Made Easy. Today we are diving into Newton's second law of motion. This law is super important because it explains how forces make things move. So let's break it down step by step in a way that is super easy to understand. Imagine you are playing a video game and you want your character to move faster. What do? You press harder on the button. Well, in real life, the same logic applies. If you push something harder, it moves faster. That's Newton's second law in action. Step 1. Understanding the formula. Newton's second law is written as the sum of all forces equals mass times acceleration. Mathematically, this is written as sigma F equals ma in equation form, sigma F equals m times a. This means the total force acting on an object is equal to its mass multiplied by its acceleration. Now let's break it down. Force represented as F. This is what makes objects move. For example, pushing a car or kicking a ball. Force is measured in newtons, represented by the letter N. Mass represented as m. This tells us how much stuff is inside an object. It is measured in kilograms, written as kg. Acceleration, represented as a. This tells us how fast an object is changing speed. It is measured in meters per second squared, written as meters per second squared, or m per s squared. The more force you apply, the faster an object moves. But if the object is heavy, meaning it has a big mass, then you need more force to make it move. Step 2. Another way to look at it. There is another version of Newton's second law. The sum of all forces equals the change in momentum over time. Mathematically, this is written as sigma F equals dp over dt in equation form. Sigma F equals the derivative of momentum with respect to time. Do not worry, it is not as scary as it looks. Here's what it means. P represents momentum, which is simply mass multiplied by velocity. dp over dt means the change in momentum over time. So Newton basically said, a force does not just change speed, it changes momentum. This version is useful when dealing with objects that gain or lose mass, like rockets burning fuel. But for most everyday situations, the simpler formula F equals ma is all we need. Real-life example. Pushing a shopping cart. Let's say you're at the grocery store and you push an empty shopping cart. It moves easily, right? But what happens when it is full of groceries? It is harder to push. Let's apply Newton's second law step by step. Given data. The mass of an empty cart is 10 kilograms. The acceleration when you push it is 2 meters per second squared. The mass of a full cart is 50 kilograms. Step-by-step calculation. Step 1. When the cart is empty, we use the formula. F equals m times a now. Substitute the values. F equals 10 kilograms times 2 meters per second squared. F equals 20 newtons. So you need 20 newtons of force to push the empty cart. Step 2. When the cart is full again, we use the same formula. F equals m times a. Now substitute the values. F equals 50 kilograms times 2 meters per second squared. F equals 100 newtons. Now you need 100 newtons of force. That is 5 times more force. The heavier the object, the more force you need to move it. Now it's your turn. Let's see if you can solve this one. Drop your answer in the comments. Exercise. A car has a mass of 1,000 kilograms and accelerates at 3 meters per second squared. How much force is needed to make the car accelerate? Give your answer in newtons and show your step-by-step solution. That's it, folks. Newton's second law is everywhere. Whether you are pushing a cart, driving a car, or even playing sports. Drop your answers in the comments below, and let's see who gets it right. If you have any questions, ask away. And if you found this explanation helpful, do not forget to like, share, and subscribe for more educational content. Until next time, keep learning and stay curious.